Okay.
Yeah.
All right. Really interesting discussion. Welcome everybody, and we've got a few people here now. We've got Abdul, Amin, Bilal, Amit, quite a few people. We are 14 people in total. I'm here twice, so I have my screen share as well. We're gonna move into the source code of Nuttx, and Alan, I want to talk more specifically about the networking side and how the networking stack is put together and how to use it in application. So maybe if we can do
Mhm.
a quick overview, just drilling down from the socket layer into the driver level uh, that deals with Ethernet hardware. So if we just can get sort of an overview, how are things put together, that would be great, I think.
Mhm. Okay. Um, just a small disclaimer. I use uh, uh, the network and other drivers, but I'm not a specialist in the network. My my drivers, my contribution are mainly about uh, the peripherals like SPI, Squared C, and others. But yes, I developed some products with Ethernet, Wi-Fi, and similar things.
Okay.
So
So
maybe
let's do a little bit about that then. So
Mhm.
you because you're working at Espressive and you're kind of focused on those IoT
Yeah,
devices. So
yes,
yeah, while I kind of do see the benefit of network in IoT, that's really close together. If you're
yeah.
working sort of more with peripherals, then let's drill down into that and kind of look at how things are put together there, because the interesting part is kind of the software architecture. So how do we plug in a custom SPI driver, for instance, and that could be
Mhm.
for an Ethernet adapter as well, like maybe a little Ethernet chip that or a Bluetooth or a Zigbee or whatever else, and that would be talking over UART or SPI, but then that needs to be plugged into the subsystem for the packets and the sockets, and maybe we can touch a little bit on that as well. But let's cover some of the software architecture that you are more of an expert in, and
Mhm.
you'll have to guide me on that so that we find the right files in the source code, and then we can look at them and kind of drill deeper into that.
Yes.
Sounds fair?
I suggest my suggestion is we do an overview about the tree of the Nuttx. So this way, other people can understand better and navigate in all these directors and understand better uh, what is inside of each director, and uh, they will realize how everything are connected and how the things work. So
Right.
yes, the first director, as you see there, is the arch. Uh, this is the basic infrastructure for any microcontroller. So inside Arch we have uh, ARM, you have MIPS, you have Extensa in the case for the ESP32 is the expressive microcontroller. And now we, as you know, I don't know if you read about it, but we have now ESP32C3. It's a RISC-V microcontroller, the first RISC-V from Expressive, and this is a good move because, as you know, the Extensa is an architecture from a company called Tensilica that was bought by Cadence a few years ago, and the Extensa is called a new a new generation of the risk architecture, because it brings the benefit from uh, uh, risk CPU, but together with some good things that CISC CPUs used to have. But okay, so as you can see, the first layer after the art director are the uh, are
Audio.
the CPUs, yeah, the specific CPUs. So ARM, AVR for Atmel, now microchip bought Atmel some years ago. Uh, we can enter inside Extensa as you did. Uh, Inside Extensa, we have a director called include. This directory is only basically include uh, not the main header files. For example, there is no specific peripherals include. They are mainly about include related to the CPU, the low level CPU, like how many interruptions, how many uh, interruptions uh, port it have, how many, uh, for example, imagine you have some different kind of ESP32, so you can define in this header if it is ESP32 standard, it will have only one Ethernet. If it is a new version of ESP, it will have two Ethernet, for example. It's just a suggestion of what is the main things inside it. So, okay, let's go back to the extensor. And finally, we have the SRC, the source. And inside source, we have the common that's uh, the code that will be common for all extensa CPUs. For example, if we have ESP32, ESP32S2, and so on, it will be inside this common directory. So inside the source, we have the ESP32, just a little bit low.
Mm-hmm. Yeah, here.
This ESP32. Okay, inside the ESP32, we have the peripherals source code. For example, like I told, to I2C, SPI, to GPIO, and so on, Ethernet, all these um, files are the driver that will bring support to the peripheral of the ESP32, or for ARM, or for for STM32, that is ARM microcontroller, for ST microelectronics, and so on. But so basically, we have all the files, all the source code that will bring the support to the peripheral. And inside this ESP32 or any other microcontroller we have a directory called hardware. This hardware is just a directory with the peripheral includes, with the peripheral source code headers. They will map all the registers for a peripheral. For example, if I have I2C in my microcontroller, I will read the data sheet, and I will define all the registers inside these files. And it's the same for all other peripherals. And this hardware directory also exists for any other microcontroller, and it exists for all the microcontrollers supported by Nuttx.
Right. Okay.
Yeah. So this is the basic idea of how the source code is organized, and inside this file you define your drive. I mean, you create the logic to get the driver working, and these drivers are called lower half drivers because they are integrated with lower these lower half are integrated with upper half driver that is common to all the peripherals supported by Nuttx. You can imagine it like it's not a hardware, it's not a hardware abstraction layer, but it's a kind of abstraction that you bring, that you let your driver, your upper half driver, to behave in the same way, no matter what architecture you are using, no matter if you are using ARM, or if you are using Extensa, V80, or any other MIPS or any other microcontroller. The way that application will interact with the upper half driver is all the same. So it's very important to create a very good lower half driver, because if your drive does implement all the functions that the upper half needs, when the application try to use it, maybe it will face some issues or it not get the best result as you expect. For example, if you are implementing I2C or for example, SPI, and you didn't implement the DMA, the direct memory access, and you try to use these drivers to interact with SPI LCD. When the application try to render, to write a rectangle or any image in the LCD, it will be slow because you didn't implement the DMA. So it's very important.
So Alan, if we were to if we were to implement, let's say, something that can you give some example of some device that you've been working on that connects over SPI?
Yes, some example, the LCD SPI, like OLED displays and many others. For example, there is
in particular that you've been working on. Maybe you can just
one. You mean one drive that I developed? Okay.
Or any driver that you have a lot of experience with that you understand.
Yes. For example, inside the inside drivers, LCD, the Max 7219. Yeah, this one. Yeah, I implemented it some years ago. I don't know if people here know this driver, but it's mainly used by the dot LED matrix, these Arduino matrix that people like to use to create some like some bus stop display. You know, this bus stop inform the bus is arriving in few minutes. So normally they use these matrix LED.
Yeah, it's like
Uh,
basically a matrix, like a LED digit display, right?
yes, is on LED, uh, is an LED display, but it's only a pixel. You mean? I mean, it's only uh, the LED is on or off. But inside Nuttx, we can map it to become a real LCD. So when I create this driver, I did exactly that. I can glue. I can connect many of these of single cell matrix to create an LCD with many lines and sorry, many columns and many rows, like lines uh, of LEDs, and I can connect it to create some animation.
Yeah.
And yeah, uh, and this driver was very interesting to implement because uh, the these Max 7219 has some small details that I need to pay attention when they are creating a driver. For example, the order that uh, the LEDs are turned on and off. And so basically what I did was I received the like a line uh, of pixels to be displayed, and I move all these uh, through all these pixels, and I will turn on and off. Yeah, this part there's uh, all on and off to this buffer to uh, to display the image. So it was really nice to implement. And also there is some uh, some presentation, some video tutorials in the Nuttx channel in the YouTube that I show how it's working from the user point of view. So yeah, this part is a good one. Is on this the clear is basically just uh, to write zeros to turn off the uh, the LEDs. But yeah, the
So let's start from the beginning here. So this is a device that implements the LCD interface, right? Let me just
yeah
go back
yeah
here. So from the system perspective, this device is a frame buffer device, right?
yeah, it's like a frame buffer device. Yes.
Yeah, and so it has the LCD Dev S, that's interface out to the application, and then the only device it's using is an SPI device. But does it have any GPIOs as well?
No GPIO.
So
Only
how do you configure, for example, the chip select pin to use?
okay. Yeah, I understood now. This is a good question because as you can see here in the driver, I don't care about these details.
Yeah.
If you look the select and deselect these functions, SPI helpers in the bottom, yeah, uh, move down and yeah, this okay. It's only okay. It's only called like a macro a function that you lock and unlock the and do the select the for this SPI interface for this port SPI port I am using. I am saying uh, to the driver please select the chip select SPI dev display 0. And now I will show you how how this display is mapped in the board. So this way the user can define what GPIO will be used for this chip select.
Right.
Okay, you can move to other director, to boards, board ARM, board ARM, STM32, yes, STM32 F4 Discover board. No, F4 Discover. Yes, this one.
429i Discovery. That one has display.
Yeah,
or
this one. Yeah, SRC. Yeah, SRC, and there is take care, because there are two Max 7219, because I did one to be used like a matrix display, but this Max 72 is also used for how to say, they are used also for segment displays.
Yeah, that's the main usage, right? But you're using it as a frame buffer because you're driving a matrix of 8 LEDs.
Yeah. This one that you open now is the right. Okay. So here we have the board LCD initialized. The chip select is not here, but it's good to show it here just to see how it is initialized. Okay, so when the board initialized, when the Nuttx initialized, it will call the board LCD initialized, this function. Basically, it is just will initialize the ESPI bus for this case, define what SPI port I am planning to use. I can define if I am using the SPI port 1, port 2, anyway, no matter what port I'm using. This only to inform to the lower half. I am interested to use the GPI 1, for example. So, and here we have the in the next function, the board LCD get dev. This is the function that you initialize the LCD and get the like a frame buffer thing. So as you can see, it you calling the max 7219 initialize, passing the GSPI dev that I just created in the previous function. Okay, it will just initialize and configure the driver that you saw in the driver LCD Max 7219. And now please open the STM32 SPI.c. Yes, this one. Now we will find the chip select for the
What should I search for?
That the video missed the O video. A display, sorry, not video. Display, display. I'm sorry. Yes. This one here, almost in the bottom. If defined max 7219 or defined LEDs max 7219, it will map the GPIO max 7219 underscore CS. This GPIO Max 7219 CS is the chip select GPIO that you are asking for.
Yeah, right. Okay.
And now we can see where this GPIO is defined. Just open the STM32F4 discover.h.
Where is that? Which one? In the
Is
discovery directory under.
yes, yes, yeah. No, the same directory is here, just in the bottom.
Ah, okay.
F4, maybe the last one. Or,
Oh, there.
Yeah, this one. Now we can search for display or sorry, for Max 7219 CS. CS. Yeah, this one. So here I can see we are using the PTC3, the STM32 port C pin 3.
So is this hard coded in this file then?
Yes, it's defined in this file for this board.
Okay.
So for each board or for each chip select, you need to define what chip select you are planning to use. In the future, when Nuttx use, for example, the device 3, it will not be hard-coded like it is currently using.
Right. Is that something that that Greg is planning to implement soon, or?
Yes, there's some guy working on it. Not working actively, but he's already started developing it. The Matthias Nitzel, and I cannot remember his last name, but his nickname is Matthias Void, or V0ID, void replacing the O by 0. Okay. And yeah, he is working on this device 3 and already implemented some proof of concept in C++, and the idea is to move it to plain C.
Right. Okay. So so that's where that CS pin comes from, and then basically you have the select function defined in your driver then, and that's how it connects to the SPI at the lowest level.
Yeah.
Yeah. Let's see. So we have. Okay, and then and these macros SPI send block is that accessing some kind of virtual interface for the SPI driver?
Yeah, the block macro is because same SPI port can be used for different external device using different chip selects. Then before using the chip select function before selecting on device, you need to block to guarantee any other driver you try to use it. It's like a mutual exclusion, like a mutex, to avoid others to try to use the port while you are using it.
Okay, right.
Yeah.
And how does this then plug into the higher level stuff? So from the application, how do you interact with this display?
Mm-hmm. Well, in Nuttx, we have two ways to create this communication with display. In the past, it was just connected using some functions that simulate like a display server, like the X11 in the Linux. But after some evolutions, where we create two other vertents, two other ways. One is using the frame buffer device, like in the Linux /dev/fd0. So this way you can access the frame buffer directly. This way you don't need to run the graphic server, and your application can just open the frame buffer and write to it directly. It is very easy and very simple. And this original server, graphic server, evolved to use some message queue. So all the communications are done by message queue, similar to X11 that use sockets, but in our case we are not using sockets, but message queues that you have a better performance and also use less resource than using the network to do this kind of communication.
Right. So everything you write to the display is you're kind of using a message that you send to the. Is it the display server or? So from the application, you're sending a message, but why is it implemented that way? Is it so that multiple threads can talk to it without worrying about any concurrency?
Yes.
Right.
Yes. Yeah.
So when you want to draw something, like you want to draw a pixel, that becomes a message that you send to this display server.
Exactly. You send a message. I want to draw a rectangle from line. For column 10, row 20, up to 40, 40, for example. So this way, it will draw but there is other primitives beside that, and you can also draw bitmaps, and it's also has support to fonts. Character fonts like letters, Japanese, Chinese, any others.
So how does that server interface then with the display? So let's say you've written this driver and you have this code working, and then you want to kind of plug this into the application as seamlessly as possible. How do you integrate it into the
after this drive is done, my board just needs to initialize it, like we saw in that file in the Max72, and it will create an interface. And if you move out of this Nuttx, you go inside apps, you can see there's some reload applications. Basically, these applications call the NX server interface, and it will go inside examples. NX, for example, NX hello or NX demo. NX demo has many demos, like it draws some lines, some rectangles, some circles, and create some kind of animation. Let me leave the full screen, and I will try to exit the full screen. I try to find the.
Do you want to share? Do you want to share your screen?
Yes, I was planning to send you the link, but I can share my screen as well.
Yeah, let's do that.
Okay.
So just click share.
Let me open my Firefox browser again. Just a second. My computer is a little bit slow because it's a Dell G3 gamer laptop, and it's a very bad laptop because it was too noisy. So I decided to remove the fan, the coolers, and I just reduced the clock speed to 900 megahertz.
Oh,
So, yeah, this way,
solution.
this way it does get too hot, but as a drawback, it's slow.
Right.
But at least it's surviving for 1 month, 1 month already. So just let you open here, and I will share the screen. Okay. Okay, it's open.
Are you able to share the screen?
Yeah, I am going to share. Okay. Share screen. Let's see. Okay. Can you see my screen or not yet?
Not yet.
Okay, probably it's
We can't see your screen yet.
not yet.
Now, yeah. Oh.
Okay. Can you guys see it?
Yeah, we can see it.
Yeah, we
Okay.
can.
Now it's all visible. Awesome.
I'll try to move to example running this one. Okay, so this NX demo that you see now is running in the matrix display.
Mm-hmm.
It starts with if a circle and then become a square, and then display a battery icon, and it's finished. So let me close here. Okay, Martin, if you want to go back to the NX demo application, we can now that we see what it's doing, we can show the code, and we can look the code and see how it's doing these animations.
Yeah.
Yeah.
Which demo is it?
Hmm?
Which demo is it?
Yeah, the NX demo, this one that.
Oh, it's okay. So it's the next demo, right? Okay.
Yeah, this one. Yeah, this one, the listener is for some NX server events. Okay, we can open the NX demo main.c. Yeah, this one. Okay, it's initializing the like I told you, it used some some NX servers functions. So you need to define some information about the background. Open now the background because it's just calling the background functions. As you can see, sorry, in the previous file, okay. Yeah, so this one, the demo background.c is doing that animation or drawing the circles. As you can see, first it starts to move. Just go a little bit up to see the initial function. Yes, a little bit. Okay, this is the demo one. Demo one is the one that you is the bouncing ball in the screen. So it just increased the X and Y lines for display the circle and change its directions. If it pass the maximum size of screen, the maximum column or the maximum row, and it will still bounce all the time. And
so, so where does this demo get the handle to the display?
As you can see in the NX demo,
it's calling things like NX draw circle. So that would be, I guess, so it creates a window, right? So there is a there is an extra layer there, right?
Yeah, it is done in the NX main demo main.c. NX demo main.c. It initializes the NX server. Yeah, these ones, please. Initialize the NX server. So it will call the NX demo initialize that will create the display instance, and the next function is it's also from the background. It will get back the background window, and
do you mean this one?
Yeah. Try to.
Which function do you want to look at? Demo one.
Move down. Yeah, demo one, demo two. I think there's other for get the window size and. Yeah.
So this gets resolution and yeah, and then it just calls a bunch of NX fill.
Yeah, move a little bit down. Let's see if we have other functions. Demo 3. After demo 3, let's see. I'm trying to find the function that return the window.
Nothing left there.
The keyboard. Let's see. Yes. See, in the app uh, in the app screen I think in the app yes, this one you open the main, right?
Mm-hmm.
uh, Put it as the main as the main screen, like that. Okay. I just saw it. There's a NX Connect that you connect to the NX server. Uh, the NX server will be started when the Nuttx starts. Yeah, this one. Yeah, here. Connect to the server. Uh, instead of using LCD, you can use the NX server if you want as well.
So what is the VNC server? Is that something that actually works like a VNC server over the network?
Yeah. If you have a board like for example, the ESP32 board that doesn't have the LCD, but you want to create some interface, of course you can use a web server to create some interface in the board. But imagine you don't want to use the web server. You just want to use like a virtual display in your board. So you can export it like a VNC, open in Linux or Windows or Mac OS, no matter, uh, like a VNC client, and you can interact with your application. So we can uh, control some buttons, some gauze or any other widget in your application.
Does that server need to have network, or can it run over a terminal?
It doesn't need to have a network. You can run it even in a board without the network. If you see in the demo that I just did, I did it in the STM32F4 Discovery board that doesn't have the network interface. It doesn't have Ethernet, Wi-Fi, nothing
Yeah.
else.
So
Yeah.
I'm just thinking, is it possible to connect to a board over the serial port and pipe the VNC protocol, or to configure the code to basically talk VNC over the terminal and then connect the VNC client to that terminal instead of a socket?
Yes, it's possible if you create some other layer for communication. For example, in Nuttx, we have uh, you know the it's a USB protocol called RNDIS, RNDIS.
Right.
Yeah, it's a kind of network protocol under the USB network, USB port, USB protocol.
Oh, right. So
And
it's like a virtual network interface. So you can basically set that up and then connect over the
yeah,
VNC server over that, right?
yeah, I use it a lot in my videos in the Nuttx channel. There's some example how to do that, uh, and you can also do the opposite. You can, for example, share the internet from your computer to your board. Imagine we have a board with this display, with the matrix display,
Mhm.
and your board, like the STM F4 Discover board, does have Ethernet, but you want to get some data from Twitter, like how many likes your post receive, or how many users are subscribed to your YouTube channel. You can get this information in your computer, and once your computer is connected to USB cable to this board can share get the internet shared from your computer. So the board can get the data directly from the internet to using your computer like a gateway, like like a bridge.
Right. That's really cool. So do you need to, is it necessary to set up a bridge in order to use that?
Uh, Good question, because like I told you, I'm not a network expert, but you need that in Linux. You need the IP forward things to good.
Yeah,
I
okay.
try
Yeah,
to.
that's a good question. That's something that people can basically just search for, but it's really interesting that Nuttx has this USB network driver that can be used as a virtual network interface.
Yeah,
I wasn't aware of
and
that, so that was something new for me, definitely.
yeah. In fact, it has two of these protocols. Their other is from Apple. It's called ECM, Ethernet Class something, the ECM. Uh, the ECM is similar to RNDs, but it's because in the past Apple didn't have the RNDs protocol, so they implement their own protocol, and it also become standard protocol for USB group, USB SIG, and yeah, and uh, someone also included it on Nuttx. So I never use it because I use RNDs, and
Yeah.
RND work good in Windows and Linux, and is all I want. I don't have Mac OS. I don't have an Apple computer, so
Oh, I actually found a tutorial you did on the Nuttx channel in 2018 about R&Ds.
yes, yeah.
I'm gonna
There's
watch
a
that later.
So,
yeah.
hello, if I can add
Hello.
something over here.
Yeah, go
Sure.
ahead.
Yeah, so Bilander, so I have like previously in my career worked on like some uBlocks modems. So they were having this basically RNDS drivers. So it's sort of like a solution where you get a very high bandwidth, for example, for data communications with the network, because it's on USB. So an upgrade on UART basically, and then as I think already mentioned that, for instance, you plug in it plug a USB into your PC, and so you can basically use that modem through your PC. What it does was, for instance, the CDC ACM or ECM NCMO, these are different USB modes, class drivers. So those are basically used for different like configurations for like if you talk about modems, so different serial ports. So you can basically, for example, CDC ACM can give you multiple serial ports on a single USB device. And if you switch to like, for example, the RNDIS mode, what you get is that you can have a serial port and you can have in parallel an Ethernet interface. So like you can configure through the serial port and you can use your AT commands or something else. And
Yeah,
then through the RNDIS, it does all the remote network like device interface that it
yes.
works properly.
It's called USB composite driver.
Yeah.
Nuttx also supports it, and so you can have, like you said, CDC ACM driver together with RNDs or any other USB drivers supported by Nuttx. Uh, there
Right.
are some examples. I didn't create a tutorial about it yet. It
Mm-hmm.
is in my to-do list. Uh, until now, I think I created about 56 tutorials, but there are more than double that in my list of to-do things.
Right, right.
And
So if I can ask, like, for instance, previously when I worked on, for example, Android, so we had like the RNDIS driver configuration, which we could basically include a driver from menu config or something. So is there a similar interface for Nuttx,
yes,
or
yes,
do you?
yes. It used the kconfig, like
Okay.
the Linux kernel, like uh, the specific IDF,
Ah, okay.
ESP-IDF. Yeah, is the same kconfig interface. And using this interface, I don't know, Martin, if you can show it. I don't know if you configure it. But
Yeah, the thing is, when I updated the source code, it no longer compiles. It complains about really weird stuff, kconfig syntax error. So maybe because I pulled the latest master, maybe it has some errors in it.
are you using the Ubuntu, the new versions of Ubuntu, or not?
I probably have to. I have pretty new version, but maybe not the latest one.
So I will send a comment to you to execute. There's a kconfig front end. I just install this package. I will copy it here in
Sure.
the. Okay, just execute. Sudo key install. Okay, I just paused it. So yeah, you don't need to compile that that package anymore, because now Ubuntu have this package.
Yeah, that's really weird. For some reason, I get a bunch of errors that looks like this. So it's like it seems there is something weird with the source code. I tried to delete it and just clone it again, but I get the same error. So I have to debug this.
Did you install the package?
Yeah, it's installed.
Please maximize your screen. I cannot see it. The
Yeah,
letter.
I'm gonna zoom in.
Yeah, the letter is too small.
Can you see it now?
Yes, a little bit, but okay. Nothing to be done. Invalid syntax.
Oh, that's too big.
Yeah, too big, and the other screen is blocking the remaining. Let's see. Okay. Yeah, it appears that as you told, you cloned from Patacongo.
Yeah.
It's not. Yeah, it's not the official repository. The official repository is in GitHub, Apache, is like incubator Nuttx and incubator Nuttx apps. But let's try to make make this clean and try again.
No, I already done that. That was the first thing I tried.
Yeah, did you?
Let me see. So Nuttx, Git, Apache. Let's see which one is incubator. Is it incubator Nuttx? Is that the official, the latest one?
Yeah, incubator is the new.
Okay.
I will copy the. I'll copy the link. Just copy this command, and this one.
So I'm already copying it. I'm just waiting for it to finish.
Yeah, as you can see, after the repository, I put the name I want to use it, because if you clone the incubator apps, Nuttx apps instead of apps, it will not find the apps directory. So you need to rename it accordingly.
No, it's the same thing. That's really weird.
It's same error.
Yeah, it's the same error.
So maybe some package, something is not correct. Maybe some like because it depends on some auto tools and other things in your computer. Maybe it's not updated. I don't know. Missing end statement for this entry.
So apparently this is an error.
Yeah, but I can't see any error in this.
No, me neither. That's really
Maybe
weird.
the build is broken. Maybe the build is broken already.
Valid. Okay. I think I know what could be happening because it's saying that function is not supported by the kconfig frontend. Open this one as well. And what is the
Which one? Where do you see that?
yeah this are what is the line?
1017.
Yeah. Okay. Good. No. Oh no. Now open this file. ARM search stm32 l4 kconfig.
But the error is in this file, is it?
Inside the file, not in this one. This one is just because it's referring to other one.
Ah, okay.
Yeah. Just return to the terminal. Let's see what line in this file.
There was no error related to this file.
I think yes, many.
Right. Okay, so first it started there, but then it continued here as well. Yeah.
Yeah. Let's see. The first one happened in 52:36. Try to open this.
Oh.
36. Yeah, I suspect is the signal greater than is not supported by your kconfig version.
Okay,
It means
right. Okay, so I'll just upgrade that. Maybe
okay,
compile it from source later.
Yeah, I'm going to suggest another thing because it is using the kconfig you compiled, not the one from the Ubuntu. If you close your terminal and open it again, probably it will use the new kconfig.
Oh, so okay.
Yeah, just close and open again the terminal and probably, or open a new terminal, probably it will work. Because I am using this same version from Ubuntu and it's working fine here. Or if it doesn't work, maybe you need to remove your manually compiled version.
Which version of kconfig are you using?
The 4.11.
So how do I check version? Does it have any command line option for that?
I think just apt info, the package name, apt info or apt show, the kconfig dash frontend.
.411.
Yeah, the same I'm using here.
Yeah.
So
So I get
maybe
the same. I get the same error if I close the terminal and open it again.
and open again. So you need to remove the the version that you compiled. In some way, it is overhead the Ubuntu version.
Okay. Yeah, I'm gonna check that later.
Mm-hmm.
But
Okay,
but can I compile? Isn't there a source of kconfig included in Nuttx?
because the kconfig is the GPL version, and we cannot include GPL code uh, in the Apache repository in Apache server, and now that is a package in the Ubuntu and other Linux distribution. It's not an issue anymore because we just need to install. Maybe we need to create a new video tutorial to explain people to install the package instead of downloading and trying to compile the old version.
Yeah. Okay.
Okay.
So shall we round it up today then?
Mm-hmm.
We are already 15 minutes past the end time.
Okay, Martin, thank you very much for having me here. And guys, nice to meet you guys. And I hope you start to take a look in the Nuttx project. I saw the many guys from different parts or different places here. Some people from China and other place, for India and other place. And there are many people using Nuttx in India. The Tata Motors using Nuttx for automotive projects, and it is good to people in India to start to learn Nuttx because eventually they can work for Tata Motors.
Mhm.
Yeah, and Tata Motors also contribute some code to Nuttx. They create the port for let's find here the Renesas RX 65N architecture or microcontroller RX 65N, and this is a nice how to say, a nice MCU, and it has many industrial interface like CAN bus and others, and so that's it. I think it's very good for people in other place to try to understand the system, to use it a little bit more, and eventually become some contributors to the project, because currently we have few developers, and we need to get more people involved and contributing and helping to evolve the project.
Yeah. Sounds good. It's quite a big project and lots of functionality. So I know that the PX4 is using Nuttx as well for their implementation.
Yes, PX4 is the most successful open source drone controller out of here. There are others that are in some way known, like the Ardu Pilot, but they are not so powerful and complete like the PX4. PX4 is a very big and very old project. It started more than 10 years ago, and they 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 are one of the oldest open source drone flight controllers that is still active even after so many years. There are others, but they eventually died and disappeared or didn't get some great community. And many of the Nuttx contributors came from the PX4 project because the PX4 bring more visibility to the Nuttx. They they were the first project to the first open source big project to embrace Nuttx.
In the drone space, everything is a copy of PX4.
Yes, yes. Even the boards, you know,
Yeah, I know. Even the boards.
the PixHawks, you can open the AliExpress and find many many clones of their boards.
Yeah, I want to get Lawrence on a talk and talk about PX4 someday.
Yeah, he's a nice guy. I think he eventually will enjoy talking about the project. And yeah,
Yeah, that will be a lot of fun, definitely.
yeah. If you get him in, please let me know, and I want to watch his presentation. Yeah, last time in last year, there was a PX4 event in Europe. I can't remember. I think it was in Holland, and his company, I think Audion, I can't remember his company name, was the sponsor, was one of the sponsor of the project because Microsoft, NXP, and others also sponsored the PX4 project.
Cool.
Yeah. And maybe in next year we have the third Nuttx event. The first event was last year in Gouda. I don't know how to say the city name in Netherlands. And this year, because the COVID, it was an online event that I promoted. I was a host, one of the hosters, and this year it was planned to happen in Tokyo, Japan, but because the COVID, we uh, we postponed the event. But we don't know if next year it will happen in Tokyo. Maybe, probably because the Xiaomi, I don't know how to say it, the Chinese phone company, Xiaomi. Probably next year it will be in China. I don't know. Let's see.
Okay. Yeah.
Yeah. You guys are invited to participate, and this face-to-face event is very good because you see many motivated people that is still working in the project. You met the developers of the project, and it is a very good energy to see these guys.
Mm-hmm. Sounds good. I definitely want to get an invite or something. So just count me in on that. Definitely, Alan.
Yeah. Normally, I post about it in the LinkedIn Nuttx group. I think you are there, right?
Yeah, I think so too. I'm gonna double check.
Okay, guys. Thank you very much, and see you later.
Yeah. Thank you, Alan. Thank you for being here, and thanks everyone else. Bye.
Thank you for having me. Bye bye.